solving exponential functions. So you will be given exponential functions and you will be solving them. So if you're given some base and that b is raised to power m, and this is equal to another b to the power of n. Note my base is the same. My base is the same. Okay. Then if your base is same and the power of them are different, then m will be equal to n. You can basically cancel the bases and your m will be equal to n. So step 1. So if you want to write the steps, will be rewrite the equation in the form b to the power of m is equal to b to the power of n. Now first step. Second step will be set m is equal to n. And step 3 will be solve for the variable. Example how you're going to do this. So if you're given, it says solve. Okay, let's do a part. It says 2 to the power of 3x minus 8 is equal to 16. You are given this thing, 2 to the power of 3x minus 8 is equal to 16. Okay. Can anyone tell me, okay, let's make factors of 16. Before doing that, let's make factors of 16. Sean?
Oh yeah.
What are the factors of 16?
1, 6. Would be 4, 4.
4, 4 you're saying. Okay, then?
2, 2. And then 2, 2 on the other side, so it would be
so basically
2 to the power of 4.
2 to the power of 4, correct. So you got 2 to the power of 3x minus 8 is equal to 2 to the power of 4. That's the first step. Rewrite the equation in the form b to the power of m is equal to b to the power of n. That means I'm trying to make my base same. I'm trying to write 16 as the same base, 2 to the power of something. And note, while making the factors, I can do that. I can write 16 as 2 to the power of 4. Sean, what's my next step?
Your next step is now to set m equal to n. So 3x minus 8 is equal to 4.
Perfect, yes. Since my base are same, my powers are different, my base just cancels and you're left with just the power. Okay, what's the next step?
The next step is now you're going to solve for the variables. Yes. So you would plus 8 to the other side.
You get 3x is equal to...
And then you divide by 3.
Divide by 3. You get x is equal to 4. And that's your
answer. It would
be
12, so it would be 4. Yeah.
Really good, Sean. Really good. So your first method you are learning is you will try to make the base same. You will try to make the base same. b to the power of m is equal to same base b to the power of n. And if you were able to do it, you will put them equal to each other and solve for the variable. Let's do one more example. You are given 27 x plus 3 is equal to 9 x minus 1. Okay. Gianni?
Yes.
Okay. Let's see here, this one. I want to make the base same. This 27 and 9. Okay.
So we got to get the variable of, or 27, which would be 9 times 3. And so then it would end up being 3 to the 4th.
No, wait. Okay. You are saying, let's make factors. You are saying 9. Can you write 9 as 27 to the power of something?
No.
No. Can you write 27 as 9 to the power of something?
Yes.
Why? 9 is 9, right? Okay, if I take 9 times 1 is 9. If I multiply 9 2 times, I get 81, right?
Yes.
3 times I get 81, you get 729. no matter what
So
I
you-
do, I'm never getting 27.
Okay.
But can you write 27 and 9, something which is common between them? What do you think? Let's make factors of both of them. 27. What are the factors of 27?
I did 9 and 3.
9 and 3. And then 9 you can further divide into
3 and 3.
3 and 3. Again, let's make factors of this 9. You're saying 3 and 3.
Yes.
Note, both of them have factors of 3, are factors of 3. So I can write 27 as 3 to the power of what?
3 to the power of 3.
3 to the power of 3, and this x plus 3 was outside. And 9 you can write as 3 to the power of 2, and you had outside x minus 1. Make sure when you're writing, make sure you put in a bracket.
Okay.
Next thing is, we have to open this bracket. You need to multiply this with the power inside. What does it become? 3 to the power of?
What are we multiplying 3 to? Sorry, I couldn't hear you.
You multiply this 3 with this whole thing here.
So it'd be 3x, and then plus 3.
No, you multiply this 3
Plus
with
9,
this
sorry.
also.
Plus 9.
Plus 9 is equal to 3 to the power of?
It's equal to 3 to the power of 2x minus 2.
Minus 2. Perfect. Now I'm done with step 1 here. Now I'm done. I was able to make my bases same and powers different. What's my step 2?
Step 2 is set m to n.
So what's the m and n?
3x plus 9 equals 2x minus 2.
Okay. And then step 3?
Then for step 3, we're going to solve for the variable. So minus 2x and then minus 9. So then you get x equals negative 11.
Perfect, yes. Very common mistake here. So if you want to make a circle here, very common mistake here. When you are distributing, when you're multiplying this 3, you have to multiply with both of them, not just one. You distribute this 3 with both of these terms, not just one. So it will become 3x plus 9. Similarly here, it will become 2x minus 2. So make sure you make right important here. Done. I want you to start doing these problems yourself. A is 5 to the power of 3x minus 6 is equal to 125, and B you will be solving as 8 to the power of x minus 2. Do these two problems right now. Start doing these problems. Leah? Is Leah here? Aiden?
What?
Yeah, okay, this problem. You can help me solve this problem.
Hold on, please.
Yeah.
So I was trying to find the square root of. Oh, is that 125?
That's 125, yes.
Oh, I wrote it as 126. Okay. So that's 5, right? 5 to the 3, I think.
Yes, it's 5 to the power of 3.
Yeah.
So you get 5 to the power of 3x minus 6 as 5 to the power of 3. That's your step 1. Step 2.
Then you subtract the 5, right?
No, no, no.
No?
When your base are same and x power are different, what do you do? Step 2 is put them equal to each other. So basically,
Okay.
5 and 5 gets cancelled. You're left with 3x minus 6 is equal to 3. Since your base was the same, both have 5. So now you can put them equal to each other. Now what's your third step? Solve.
Plus 6 to the other side. 3x equals 9, so x would be equal to 3.
Perfect. Good idea. Jade. Jade.
Yes.
Yeah, this question here.
Do you want me to say all the steps?
Yes.
So I first factored it out. So I got 2 to the power 3, parentheses, x plus 2 equals 2 to the power 2, parentheses, x minus 3. And I distributed the powers to the expression. So I did 3 times x plus 2, which is 3x plus 6. And then I got equals 2x minus 6.
Okay, that's my step 1. Okay.
And then you just equal them together. So it'd just be 3x plus 6 equals 2x minus 6. You minus the 2x on the left side, and then you minus the 6 to go to the right side, and you get x equals negative 12.
Negative 12. Correct. Really good, Jade. So this is how you do. First thing, if you see exponential functions, first thing when you see exponential functions, you're gonna try to make the same base. You will try to make the same base. You will try to make the same base. That's your first step. Always, whenever they say solve exponential functions. Next method is, suppose if I say here, example, if I say here, solve 4x is equal to 15. I say solve this thing now. Factors of 4 is 2 and 2. If I make factors here, 4 is 2 and 2 and 15 is 3 and 5. They don't have the same factors. You cannot write them both as something to the power of something, the same thing. You cannot write both of them to the power of same thing. So what you're going to do in this case, first thing, you will always try to make the same base. If you cannot do, then you're going to use, so you're going to use these things now. Use logarithms to solve exponential functions. So next thing you're going to go to is logarithmics to solve exponential functions. And how do you do it is, I'll give you the steps. Step 1. Okay. Isolate the exponential expression. So if you were not able to make your base same, what you're going to do is take the exponential term on one side, everything else on the other side. That's how you isolate the exponential expression. Okay. Step 2. It says, take the common logarithm. Basically they mean just taking log on both sides for base 10. But you have to make a note here. Take natural logarithm, that means ln for bases other than 10. Step 3 is solve the Very. So what do they say by this thing is, what do they mean by this thing is, first of all, you're going to keep the term which has the exponent on one side and everything else you're going to take on the other side. Next step says, you will see in the question. See if you see 10, 100, 1000, 10,000, something like this. If you see like that, you're going to take log. You're going to take log. Otherwise, you will use ln always. Only if you see in the question something as 10, 100, 1000, factors of 10, you can, if you see like that, then only you will use log. Otherwise, always in the question, you're going to use ln and then solve. Example, you will get this with example. So you are given 4 to the power of x is equal to 15. Okay. Note 15 I cannot write as 4 to the power of something. And if I make factors, they don't have the same factors which we already tried. So next method is this method. I'm going to go to this method now and try to solve using this method. It says isolate the exponential expression. That means I need the exponential term on one side, everything else on the other side. And in this question, it is already isolated. See, my exponential is already on one side. And this number 15 is on the other side. So my step 1 is done. I will directly go to step 2. Okay. Do I see in the question 10? I don't see number 10 here in this question. I see 4 or 15. When you don't see 10, you will always take ln on both sides. So it becomes ln 4x is equal to ln 15. You will take ln on both sides. If you see 10 here, you're going to take log, but otherwise you will always take ln on both sides. Step 3 is we need to solve this. Okay. How do you solve? Remember the property we did for logarithmic. If you have log some base m to the power of p, what did it do with the power? It will throw in front. It becomes log bm. It throws this power in front. Similarly with this question, this x is in the power. This log will throw x in the front. You get log this thing ln 15. Note, now I just need the value of x. So I don't need ln for its multiplying. I divide ln for both sides. I get ln 15 over ln 4. And you can solve using calculator and find the approximate value. Take out your calculators and solve. So you turn it on. So you have here ln here. So you press ln 15, close the bracket, divided by ln 4, close the bracket, enter. Which is approximately, these two curly lines means approximately it is 1.95. The answer.
Miss K, if this is on our homework, will we have to get the exact number, the decimal?
If the question will say up to 2 decimal places, or if it does not say decimal places, just put your answer like this.
Okay.
Miss K, can you please go over again where we would use log 10
So you
right
will
before
see here.
step 2?
The thing is, let me do one more question, Gianni. After that question, I will explain because you will get to know then.
Okay, thank you very much.
Yeah, let me do one more question. Otherwise, if you don't get it, then I'll explain this part again. So the next question which is given to you is, you're given 10 to the power of x is equal to 120,000. You have to solve this and find the value of x. Note if I make factors of this 120, okay, 10 I know is 2 and 5, but 120,000 if I make factors, it is going to be 2, okay, you get 60,000, then 2, 300,000. Note here, okay, if you keep on doing, you will never get the same factors. You will never get the same factors. You cannot write 120 and 10 as the same base. as the same base. So that means I have to go to the second method. So when you go to the second method, what you're gonna do is, first step, isolate. Keep the exponential term on one side, the other terms on the other side. And in this case, it is already isolated. So I'm not doing my step 1. Okay, but let's do step 2. Step 2 says in the question. So let's see here. Jamila?
Yes.
So you're given here. Okay. Step 2 says in the question, if you see a number 10, do you see number 10 here?
Yeah.
Okay. If you see number 10, you're going to take log. So I'm going to take log on both sides. If number 10 was not there, like in previous example, I would take ln.
Okay.
Yeah. So we took log on both sides. Now how do I solve this?
Because there's an x as the exponent, you put it like on the other side of the log.
So it becomes x. X log what?
10
Is equal to?
log 120,000.
Okay. And then how do I solve for x?
And you just divide log 10 on the other side too, or to both sides.
Okay. It becomes log x is equal to log 120,000 over log 10. Good.
Miss K,
Yeah.
when you have it as log 10x, doesn't it just become x is equal to log 12?
Yes, because log
Okay.
that becomes just directly x. So here, if
So
you,
you don't-
here,
Would you still divide by 10?
no, you will not.
Okay.
That's what I was about to do this one. So here, if you see, the property, if you remember, log, the reason we are taking log is not ln is because log, if you see 10 to the power of x, when same base, this thing is basically just directly equal to x. So if you see something as log 10 to the power of x, it is directly equal to x. So you don't have to do these steps. This becomes wrong. From here, directly this is equal to x is equal to log, you get 120,000. That's the reason we are taking log, not ln, so that we can directly solve it. We don't have to do this simplification part. Remember these properties. Log 10 to the power of x is directly equal to x. Okay, try these problems yourself right now. You have to solve 5 to the power of x is equal to 134, and then second you have to try 10 to the power of x is equal to 8,000. Gianni, did you get it? Why we are using log and ln?
Yeah, it makes a lot more sense. Thank you very much.
Okay, yeah.
So technically, when it comes to using logs, the answer is always going to be the other side of the thing, if that makes it easier.
If you're it's not compulsory, you'll see. We'll do more problems, you'll see. It's not compulsory that this will be the only answer. What if
Okay.
what if I had here 2x rather than x in the power?
How do you know whether you're using ln or a log?
Okay, so see here in the previous question, if you don't see 10, if you don't see anywhere 10, here I had 4, here I had 15, I don't see 10 here, then always I will use ln. But if you see specifically 10 number, which I see here, then you're gonna use log. Did you get it, Ko?
Yes, that makes sense.
If it's like multiple of 10, like if it was like 20 or something like that, would we still use log?
No, not 20. 10, 100, 1,000 to 10,000 like this.
Okay.
Yeah.
Okay. Thank you.
Yeah. Jasmine?
Yeah.
Okay. Can you help me solve this one?
So first, it's already on the other side, so we don't have to do anything.
Mm-hmm.
So we just take the natural log of 5x, and then natural log of 134.
Okay.
And then from there, we just move the exponent up to the front.
Mm-hmm.
And then divide by the 5, ln natural 5 on both sides.
And can you use a calculator and tell me what do you get your approximate value up to 2 decimal places?
3.04.
You're saying 3.04. Yes, you're correct. Okay. Cameron,
Yeah.
let's do this one.
Okay, so since it's 10 and 8,000, like the exponential's already separated, we don't have to worry about that. And then you would take the log of both sides because it's 10 and 8,000.
Just 10.
So
Just 10. Not 8,000, just 10. 10. You will take log if you see 10, 100, 1,000. Okay? Not 8,000.
Okay. And then it's log 10x to the x, and then log 8,000 equals log 8,000.
Mm-hmm.
And then x would equal log 8 or
Log
8,000.
Yes. And when you solve using calculator, what did you get approximately?
I didn't take the log. Let me do that right now.
Mm-hmm.
3.90.
Yes, it's 3.90, correct. Let's do more problems on this. So you are given 40 e to the power of 0.6x minus 3 is equal to 237. Minhan?
Yes.
Okay. Can you help me solve this one?
First you get rid of the negative 3 on the other side, so it's going to be 240.
Yes, so you get 40 e to the power of 0.6x is equal to 240, correct?
I'm not really sure what to do next.
See, I just want the exponential. This is the exponential term, e to the power of something. This 40 is extra. I want to get rid of this 40 also.
So you divide it by 40?
Yes, you divide it by 40 both sides. So you get e to the power of 0.6x is equal to what?
6.
6. Yes, correct. Now, Minhan, you have exponential term on one side, constant on the other side. How do you solve this? Do you see 10 anywhere?
Isn't E already 10?
E is not 10. E is not 10.
Oh,
So there is no 10, right? There is no
no.
10. So what you're going to take? You're going to take natural log or common log?
Natural?
Yeah, which is ln, right? ln.
Yes.
So you get ln e to the power of 0.6x is equal to ln 6. And how do you solve this?
You divide it by E to the power of 0.6x.
No. Minan, okay. Can you tell me what is ln? Log base what?
Log base 10.
That's just log. If I just write log, that's log base 10. When I say ln, it means my log base is e. Okay, always. Okay. So if this is log base e, okay, if basically this is log base e to the power of 0.6x is equal to ln 6, what do you get?
That's 1 to the power of 0.6x.
So basically there was a property. If you have log base b to the power of m, your base and this number are exactly the same. It is just equal to m. So you get here 0.6x is equal to ln 6.
ln 6.
Okay. And then how do you solve for x?
You divide by 0.6.
Okay, you divide by 0.6, you get equal to x is equal to ln 6 over 0.6. Can you use calculator and tell me what answer did you get?
Okay, 1 second, please.
When you say 0.6, like 0 like times 6 or like literally
No,
0.6?
0.6. It was 0.6.
Okay.
It's 2.98, and we round it to 3.
2.99. So it will become up to 2.99. You leave up to 2 decimal places.
Okay.
Yeah. So note in this case, guys, first you have to isolate it. In previous example, it was already isolated. Once you isolate it, you're taking ln on both sides since you don't see any 10. And you have to remember the properties. Log 10 to the power of m is also equal to m, and ln e to the power of something will be equal to also that thing. So here this basically just cancels, you're left with 0.6x. Once you're done with this, I want you to try this problem yourself right now. You are given, you have to solve 7 e to the power of 2x minus 5 is equal to 58. Solve this right now. Jaden? Not here, Jaden. Alexander?
Yeah.
Okay.
So our first step would be adding the 5 to the other side.
Okay, you get 7 e to the power of 2x is equal to
63, so 63.
yeah.
And then we got to get rid of our 7, so divide by 7.
Okay, you get e to the power of 2x as
2 as 1 second. By 9.
yeah. Okay, then what you're gonna do next step?
And then you make it, since there's no 10, it's going to be ln e to the power of 2x equals ln 9.
Yes, correct.
And then because it's a ln e, you could just eliminate the ln e, so it just becomes 2x equals ln 9.
Correct.
And then because you have 2x left, you divide by 2,
Okay, you get x is equal
both
to
sides.
Mm-hmm.
And then it becomes x equals ln 9 divided by 2, which is 1 second. Let me get my calculator. 9, which is 1.09.
1.09, right?
Yes.
Around
Why did we get rid of the ln e? Like, why did we?
because there is a property ln e to the power of m is just equal to m. That's a property because ln is basically log e, so e to the power of m becomes m.
Ms. K, do you want us to round up for our like estimates?
If the
Or
question says so, this is one of the important questions. So if you want to mark here important here, so you are given 5 to the power of x minus 2 is equal to 4, 2x plus 3. You're given this thing. Note in this case it's already isolated. Exponential is on one side and this side also there is exponential. So exponentials are on both sides. They isolate. They are by themselves. Okay. I cannot write 5 as 4 to the power of something. Neither I can write 4 as 5 to the power of something. They have completely different factors. 5 has just 5 factor. 4 has 2 and 2. So I cannot write them as the same base. So next method I'm going to go to is the logarithm method. Let's see. Jamie?
Yeah.
Okay, so next method I'm going. So what you're going to do? It's already isolated. What's the step 2?
I'm not sure.
Will you take log or ln?
Log.
You're gonna
Or
take,
ln, sorry.
because
ln.
you don't see 10 here, you're not gonna take ln. So it becomes ln 5 minus 2 is equal to ln 4 2x plus 3. What's the next step?
Sorry, I'm writing it. The next step. I'm not sure.
How do you get this power? What happens to this power? What's the property says? If you have ln some b to the power of p, what happened to this p? What happens to the p?
Oh, does it get moved to the front?
Yes, it gets moved to the front. So let's move this whole power in the front. It becomes x minus 2. Note I'm going to put in a bracket since there are two terms. It becomes ln 5 is equal to, for here also it becomes 2x plus 3 in a bracket ln 4. The reason I'm putting bracket because there are two terms, not just one term in my power. Okay. Can you open this for me, Jimmy?
Yeah, so would it just be
X.
x minus 2?
Multiply x times ln 5. You're trying to distribute first.
Oh, so ln x?
X ln 5. Then minus 2 ln 5.
Oh.
First you get x, multiply x with ln 5, you get x ln 5. Then you had minus 2, multiply minus 2 with ln 5, you get minus 2 ln 5. Can you tell me this side, what do you get?
2x ln 4 plus 2x or 3 ln 4.
3 ln 4. Correct. Now you have here 4 terms, Jamie. 1 x ln 5, 1 2 ln 5, 1 2x ln 4 and 3 ln 4. Okay, there are 4 terms. I want to take the terms which have x on one side and terms which don't have x on the other side. How do we do it? This term has x. Okay, let's keep this side. This whole term also has x. I want to take it on the other side. How do I do it?
Would you subtract it from both sides?
Yes, you subtract it from both sides. You're correct. So I subtract 2x ln 4 from both sides. So what I get is x ln 5 minus 2x ln 4, and then you have minus 2 ln 5 is equal to 3 ln 4. Now this thing does not have a x in it. This term does not. How do I take this on the other side?
You add it to both sides?
You add both sides. So you get 2 ln 5, you add on both sides. So basically you get x ln 5 minus 2x ln 4 is equal to 3 ln 4 plus 2 ln 5. You got this thing. Okay. Once you did that, these both have x. These both have x. I want to take out x common. I took out x from this thing. What I'm left with? 2x. It's just 2. You took out x, you're left with just negative 2 ln 4.
Oh, okay.
Okay, is equal to, you get 3 ln 4 plus 2 ln 5. Okay. Now this whole thing, x times this whole thing. Okay, I just need x. I don't need this whole thing. How do I get rid of this whole thing?
Would you divide? I'm not
Yes,
sure.
you're correct. This whole thing is multiplying, so with this whole thing I want to divide both sides. So you get ln 5 minus 2 ln 4. So basically your x is equal to 3 ln 4 plus 2 ln 5 over ln 5 minus 2 ln 4. You're correct. And if you use your calculator, you can always find your answer using calculator. How you're gonna use is, so first open the bracket for the numerator. and inside the bracket you're gonna write 3 ln 4 close the bracket plus 2 ln 5 plus 2 ln 5 close the bracket and close the bracket for the numerator divided by open the bracket for the denominator, then you write ln 5 close the bracket for the ln, then you have minus 2 ln 4 close the bracket and close the bracket for the denominator, and then you press enter, you get negative 6.34. This is an important kind of question because if this comes in exam, it will be easily worth 5 marks at least. You need to know how to solve this. I want everyone to try this problem by themselves. You are given 3 to the power of 2x minus 1 is equal to 7 to the power of x plus 1. Do this right now. Kylie.
Yes.
So Kylie, let's see this problem here. How do you do this?
Okay, let's do this problem.
Yeah.
So the first thing you would do is put ln and do like ln 3 with the power of 2x minus 1, and then ln 7x to the power of x plus 1.
Okay.
And then what you do after that is put the power in front of the ln. So you would do 2x minus 1 ln 3, which is equal to x plus 1 ln 7.
Okay.
Sorry if my clothes fell when I hit the car.
And then the second thing you're going to do is distribute.
Mm-hmm.
So 2x times 3 is 6x.
No. It's not 3. It's ln 3.
Oh.
So you cannot multiply.
ln 3. Okay. And then minus 1 ln 3.
1 ln 3. Okay. Is equal to?
Is equal to x ln 7
Mm-hmm.
plus 1 ln 7.
Okay. Then what's the next step?
And then your next step is to subtract the ln 7
So you want to subtract ln
from both sides?
Okay, you subtract ln 7 on both sides. I get 2x ln 3 minus ln 3 minus ln 7 is equal to x ln 7. Okay.
And then the next thing you're going to do is to minus 2x ln 3 from both sides.
You're correct. 2x ln 3. So you get minus ln 3 minus ln 7 is equal to x ln 7 minus 2x ln 3. Correct.
Yes. And then what you're going to do next is greatest common factors.
Yeah, so I take out x
for the
common.
x's. So you take out the x, and then in the parentheses will be ln 7 minus x ln 3.
No, 2 ln.
Or minus 2 ln 3.
Yes,
Sorry.
correct. What's the next step?
Your next step is to divide minus ln 3 negative ln 7, and then over,
Minus 2 ln 3. So
on both
basically-
sides.
Basically, you get x is equal to, good, really good. Can you use a calculator and tell me the final answer?
I have a question.
Yeah. Gabriela, Gabriela, I cannot hear you. Gabriela?
Jump on the 8.
Let her come say. Did you get an answer for this thing?
Not yet. I'm doing it right now.
Okay.
What if like you did it like an opposite way where you would went on the opposite sides?
Then your answer would be ln3 plus ln7 over negative ln7 plus 2 ln3. They both are the same thing. Either you will get this answer or this answer.
I'm having a little problems with it because my calculator keeps on putting it as an error.
Okay, so what happened is see, turn on your calculator. Let's do together. Okay. For the numerator, first open the bracket. Open the bracket for just the top part. Okay. Then you write, you're going to use this minus sign. Note, you're not subtracting, you're putting a negative sign in front. So you're going to use this minus sign. So it becomes minus ln, and then you write 3, close the bracket. And then you're subtracting, so this minus will come. Minus, then you put ln 7 and close the bracket for the ln. And now we're done with the numerator, so we're going to close the numerator bracket also. Divided by. Okay, open the bracket for the denominator. Write ln 7 minus 2 ln 3 and then close the bracket. Oh, wait, see, I did wrong. I did not close for 7, so it's not gonna give me an answer. I'm gonna write it again. Let me go. So it becomes, I'm gonna write it again, so it's gonna be open bracket minus.
Okay, you can just insert, right?
Yeah, you can do that, yeah.
Oh.
Minus ln 3 you get, close the bracket, then minus ln 7. Make sure you close the bracket for the ln. That's what I did wrong. Close the bracket and then close the bracket for the numerator, divided by, then again open the bracket, you get ln 7, close the bracket, and then you put minus 2, then open bracket 3, close the bracket, and then close the bracket for the denominator and press enter. You got your answer, 12.11. Did you get your answer, Kylie, or no?
Yes, I got the same answer as you.
Perfect. Yes, Tracy.
I'm a little confused on how you got like negative ln 3 minus ln 7.
Did you get this answer, Tracy? The bottom one?
No, I got a different answer.
Oh, you got different answer completely? Okay.
Yeah.
So, till which step? Did you get till this step the correct?
So I got the 2 plus ln 7?
Yeah, see here.
Oh, I didn't see the plus 1. Okay, never mind.
Yeah, you got it.
Hey, Ms. K.
Yeah.
Gabby asked in the chat, she said, does it matter which side you subtract from first?
No, it does not matter. It does not matter which side you subtract first. You just have to take x terms on one side and constants on the other side. Like she took it on this side, all the x terms. Usually I take it on this side. It does not matter, still you're going to get the same answer. Yeah. So next type of question is, so we did so far 2 kind of questions. First, you will try to make your base same. Okay, if the bases are same, you put the powers equal to each other and then solve. If you cannot make the base same, you're going to isolate and try to isolate the exponential term. Okay, and then you will decide whether you're going to take log or ln and then solve. So these are the two methods we did so far. Okay, next method we are going to is, so you will be given a problem like, okay, you'll be given like solve e to the power of 2x minus 4 e to the power of x plus 3 is equal to 0. You will be given something like this. Note, this thing looks like my quadratic function. This thing looks like my quadratic function. Okay, and when it looks like a quadratic function, let's make it a quadratic function. I'm gonna have, first step will be substitute. I'm gonna substitute. I substitute e to the power of x as u. The reason is why when I substitute, it becomes u to the power of 2, because e to the power of x became u. You are left with u to the power of 2 minus 4u plus 3 is equal to 0. Okay. Can I have Gabriela? Hers not working. Andrea?
Yeah.
Okay. Can you tell me how to solve this equation here? U square minus 4u plus 3 is equal to 0.
Do I subtract the 3 to the other side?
This is quadratic. How do you solve quadratic formula or quadratic thing? Use quadratic formula. Remember, you know quadratic formula. What's your a, what's your b, and what's your c?
Oh, so I would do negative.
What's your a?
Negative 4u.
Yeah. A is u squared, b is negative 4u, and c is 3. It's not u. You just take the numbers. What's next to u square?
2.
In front.
Oh, nothing. A 1.
1. So your a is 1, b is negative 4, and c is 3. Can you put in the formula and tell me what do you get? Negative?
Yeah.
Quadratic formula. Minus b plus minus square root of b square minus 4ac over 2a. This was your formula. And here you don't have x, you have u. So you will get u is equal to
I'm solving it right now. I'll let you know in a second.
negative 4 plus minus square root of negative 4 square minus 4ac over 2a. So you get 4 plus minus square root of 16 minus 12 over 2, which is equal to 4 plus minus square root of 4 over 2 plus minus 2 over 2. So basically you get u as 4 plus 2 over 2, and you get u as 4 minus 2 over 2. And you get u as 2 over 2, which is u is equal to 1. Did you get your 3 and 1? And 3 of u, you're going to substitute back. So it becomes e to the power of x as 3, e to the power of x as 1. And how do you solve this now? Which method? The first two methods we did, Andrea, which method you're going to use? The first one or the second one?
Are we using ln?
Yes, you're going to take ln on both sides. So it becomes ln e to the power of x is equal to ln 3. Here also ln e to the power of x is equal to ln 1. When you solve, what do you get?
X is equal to ln 3.
Perfect.
And x is equal to ln 1.
And what is ln 1?
0.
0. So you get ln 3 and 0 as your answer. Note, in this specific question, you have to substitute e to the power of x as u. Try this problem yourself right now. So you are given, you have to solve e to the power of 2x minus 8 e to the power of x plus 7 is equal to 0. Solve. Mason. Not here. Carmen.
Yes.
Okay. So you're gonna help me solve this one.
Do you want me to do it fully before I walk you through it?
No, you can walk me through it while you're doing it.
Okay. So you would put it in quadratic formula. So it's u to the power 2 minus 8u plus 7 equals 0.
And you substituted u as what?
What?
Why are you substituting u as what? What's your u?
U equals e to the power of x.
Okay, perfect. Then after that, what did you do?
And then you're going to convert it to the formula.
Okay. Use
but
the formula.
A equals 1, B equals negative 8, and C equals 7.
Okay. Use a quadratic formula and give me the values of u. You don't have to tell me the steps. Just give me the values of u.
Okay.
Final values.
Negative. So, do you want me to give you the final answer from the quadratic formula?
Yes.
So, when I did everything, it was 8 plus or minus 6 divided by 2.
Okay. Okay, so what is 8 plus 6 over 2?
It's 7.
7. And what is 8 minus 6 over 2?
1.
1. Okay. Now u was not in the question. You put it yourself. So I'm going to substitute back. And how do you solve these?
You would put it back into the e to the power of x, right?
Yes, I did already, yes.
So then it'd be,
so I need to find this value of x. I have got e to the power of x as 7. How do I solve this?
By the ln.
Yes, ln on both sides. So it becomes ln e to the power of x is equal to ln 1. What is ln e to the power of x?
It's x.
X, you get x as ln 7 and here you get x as ln 1. What is ln 1?
Hold on. It's just 0.
It's 0. So you got yours x as 0 and x as ln 7. Don't, if you leave your answer here as 7 and 1, you won't get any marks for this. So make sure you substitute back your ex. That's a very important step. So basically, today we learned so far is how to solve exponential functions. And exponential functions, we did 3 methods. First, you will try to make your base same. If your bases are same, put powers equal to each other and you are done. Next thing what you do is, if you cannot make your base same, isolate the exponential term, then decide if you want to take log or ln on both sides and then solve. Third method we did here. which looks like quadratic, in which you're going to use substitution method. You substitute u as e to the power of x and then solve. So these are the three methods for solving exponential functions. Next thing we're going to is logarithmic functions. Now we're going to learn how to solve logarithmic functions. So the steps are, step 1, it says express the equation in the form log b m is equal to c. So basically now we are doing the same thing. You're gonna keep the log function on one side and constant on the other side. Okay, so isolate the log function, that's what it means. Step 2 is so you are given, okay, you have to convert this whole thing into exponential. Convert logarithmic to exponential. So you're going to convert logarithmic to exponential. So if you're given log b m is equal to c, how do you convert into exponential? We already did this. Take this base on the other side and it will go in the power. And it will become m is equal to b to the power of c. That's how you convert. So basically once you have this log on one side and constant on the other side, you're going to convert logarithmic to exponential. Third, solve for variable. And fourth, very important step here, fourth one, it says check proposed solutions in the original equation. Include in the solutions only values for which m is greater than 0. So basically if your log of what you are finding, that should be always positive. You will look for values which make this thing positive, this m positive. Example, so you're given log 4 x plus 3 is equal to 2. You're given this thing, log 4 x plus 3 is equal to 2. Okay, you need to solve this one. Okay, let's see. Maximus.
Yes. Hi.
Hi. Okay, convert this into exponential.
Is that x plus 3 equals 4 to the power of 2?
Yes, exactly. It gets x plus 3 is equal to 4 to the power of 2. You're absolutely correct. What is 4 to the power of 2?
16.
16. So you get x plus 3 is equal to 16. How do I get x?
How do you want me to solve for x?
Yes, solve for x. Yes, that's
okay.
what it says.
Subtract 3 from both sides.
You get x is equal to 13.
13, yes.
But you're not done. You have to check. You have to check here. And 0, which is positive. That means this is my answer. So basically whatever...
Okay, so as long as the answer is positive, it's correct?
Yes, exactly. Only your m should be positive. I don't care about anything else, but your m here should be positive. If it's negative, it's not your solution. If it's positive, that's your solution. Really good, Maximus. Okay, let's do one more problem here. So you are given 3 ln 2x is equal to 12. 3 ln 2x is equal to 12. So can I have Faith?
Hello.
Hello. So let's see. First you need to keep ln on one side, everything else on the other side. How do you do that?
I
I'm a bit unsure, but would you put the 3 back into a power instead of in front of the equation, or would you leave it as is?
You can do that also. That's not wrong. You can do that also. What you can do is 3 is multiplying with this whole thing, right?
Yes.
So you divide by 3 both sides. You can do that also. It becomes ln 2x is equal to 4. But what you said is correct too, Faith. It's not wrong. If you put 3, it will become 8x cube here. It will still give you the same answer. Okay. What is ln?
Log e.
Log e, and then you have 2x is equal to 4. If I now, once I got my ln on one side and constant on the other side, I have to convert into exponential. When you convert into exponential, what does it become?
It becomes 2x is equal to e4.
E to the power
4.
I just need to solve for x. How do you solve for x?
Divided by 2.
Divided by 2. So you basically got x as e to the power of 4 divided by 2. But I need to check. I'm not done here. Check. What's my m?
Your m was 2x.
2x. So let's put here. You get 2 times e to the power of 4 divided by 2. Let's use calculator and see e to the power of 4. So turn it on. Okay. So you have basically 2 times, okay, e is just before here, e to the power of 4, okay, enter, and then that whatever answer you get to divide by 2, which is 54.598, something like this. Is this positive?
Yes.
It's positive. So this is my answer. So you check by putting in the values and see if you're getting greater than 0 or no. Only for m you have to check. Your m should be positive. Okay. One more question, I want to do is, so you are given log 2x plus log 2x minus 7 is equal to 3. You need to solve this thing. Okay. Kaylee?
Yes.
Okay, Kelly, let's see this one. How do you do this? Now there are 2 log functions. I've never taught you for 2 log functions. But can I convert these 2 into 1?
Yes.
So what does
and isn't that by like the condensing? So like you would turn it into multiplication because it's adding?
Yes, correct. Same base I can condense. So it becomes into?
So it'd be log base 2 and then x and then parentheses x minus 7.
Yes, correct. Absolutely. Is equal to 3. Okay. How do you now, you have log on one side, constant on the other side. How do you solve this?
Would you divide?
See here. So we first step 1, see. So your step 1 was express the equation in the form log on one side, constant on the other side. You did it. Your step 2 is to convert log to exponential now. So convert this into exponential.
I'm not exactly sure how to do that.
So this 2, whatever was your base, will go on the other side, okay? And this push this on the top. It will become your power.
Okay, so it would be 2 log. Oh, okay.
And here on this side, you will be left with just x minus 7, whatever was here with the log.
Okay.
That's how you convert it. Take this 2 on the other side, it pushes it on the top and you get this thing. Okay. Next thing we need to solve this for x. What is 2 cube?
8.
8. And here if I open the bracket, what does it become? X times x is?
X squared minus 7x.
You got this thing. Now I cannot isolate here. This is a quadratic. So I have to take everything on one side. So you get x squared minus 7x minus 8 is equal to 0. Can you use quadratic and tell me what are the x values you're getting?
Yes. I don't think I'm doing this right because I got, for one of them, I got 10 and then I got.
Okay, let's see. What's your A?
So my A is 1.
B is?
-7.
And C is?
-8.
So you get x is equal to 7 square 49 minus 4ac over 2a. So it becomes 49 plus 32, right?
Yes.
Over 2. So you get 7 plus minus square root of 121 over 2. No, it's 81. Sorry, 81. Did you get this thing?
So then it's 7 plus or minus 9 over 2.
Yeah, plus or minus 9 over 2. 7 plus 9 is?
16.
16 divided by 2 is?
8.
8. 7 minus 9 is?
-2.
Negative 2 divided by 2 is?
2. Or sorry, 1.
Negative 1.
Negative 1.
Negative 1. So you got x as -8 and -1.
Mm.
Note here, Kelly. Okay. My first step said isolate log. I did this. Convert into exponential. I did this. Solve for the variable. I did this. But I have the fourth step also in case of log. They want me to check. What do I have to check? What's my m in this case? What's my m?
Is your m x minus 7?
X and x minus 7 both.
Okay.
It's, see here, this is also my m and this is also my m. So you have both. So for both you have to check. Let's check for just first x. Okay, let's check for one here, x. When I put here 8, it is positive, right?
Mm-hmm.
When I put here 8, is it positive? What is
Yes.
8 minus 7? 1. It's positive,
yes.
right? So this is definitely my answer. Let's check for -1. When I put here x as -1, this becomes negative, right?
Mm-hmm.
So that means this is not my answer. My only answer
Okay.
is x is equal to 8. Everyone, very important step here. Why is -1 not my answer? You have to check. Put here -1. This makes this term negative. So that means this is not my answer. My m should always be positive here. Today's topic was really important. If you get questions on this, it will be at least worth like